All right, last example of finding critical values. Keep in mind critical values are when the derivative, so h prime of x in this case, is equal to 0 or undefined. We've got to make sure we think about both of these cases. So let's go ahead then. If that's the case, we need to find the derivative. So I want to make sure I analyze my structure here. One thing I notice is that first term is actually, really sine of x. Running out of space up there. Let's just do it down here. Sine of x squared, right? So it's really a chain rule. So when we go to find the derivative, I want to keep that in mind. So I know h prime of x then will be 2 sine of x, that's the outer function, times the derivative of the inner function, cosine of x. And we'll actually have, it's plus a negative sine of x, so let's just say subtract sine of x, because that's the derivative of that second term, right? So then, knowing our derivative, I then want to set it equal to 0, so 2 sine x, cosine x, subtract sine x. And when I look at this, like what it jumps out to me is a 0, it's set equal to 0. It reminds me of factoring, it reminds me of quadratics. I mean, it has two terms, like I could just get it all, so that's what I'm going to do is I'm going to factor this. So let's go ahead and factor sine of x out of there, and we get 2 cosine of x, subtract 1, and that's going to equal to 0. So then the question becomes, what angles would make this happen, right? So I know that sine of x would be 0 when x is 0 and pi. And I know that, let's see the other one, 2 cosine of x minus 1. So if I set that equal to 0, then I know cosine of x is equal to 1/2. And I know that that occurs at, first quadrant, pi over 3, and fourth quadrant, 5 pi over 3. And I only need to worry about these because they told me on 0 to 2 pi, right? And that's why over here, notice they did not include 2 pi, did not include the endpoint, and that's why I didn't include 2 pi there as well. So that's how we could find the critical values here. Now, the other option, right, we have to still consider that. So is this ever undefined? And there's no value that I can plug in for x into the derivative that would make this thing undefined. So I don't actually have to worry about that one in this case, but I should make a note of it.